Exam review, we've got a few problems we need to go over. Number one, be able to substitute values into a function. Often the function describes some real-world modeled scenario. Be sure to note what each variable represents and substitute as requested. So I have an example here. The function f of x equals negative 0.002x squared plus 0.66x models the path of a softball that is hit for a home run, where f of x gives the height of the ball and x gives the distance from where it is hit in feet. How high is the ball when, I got a typo, the it is 4 feet away from where it was hit? How about when the ball is 4 feet away from where it was hit? So, takes the video for me to edit. Let's get rid of this. Okay? And I will get to that soon, but you don't worry about it. So how high is the ball when it is 4 feet away from where it was hit? So again, f of x gives the height of the ball. So f of x is what we're looking for. You need to know how everything is measured, and f of x is the height, and x gives the distance from where it was hit. So x is distance from where it was hit. I'm just going to put distance from hit. So it says how high is the ball when it is hit 4 feet away from where, how is the ball when it is 4 feet away from where it was hit? Okay, so I have x is equal to 4, so I need to find f of x. So f of 4 is equal to, just plug 4 in, so negative 0.002 times x, so 4 squared, plus 0.66, remove the x, and replace it with 4. So again, notice what I did. This is just regular function notation. I'm supposed to plug in a 4 everywhere there's an x, and notice that's what I did right there. And when I type that in my calculator, remember, you need to square first, then multiply. So this would be negative 0.002 times 16 plus 0.66 times 4. Then we'll multiply and then finally add. So negative 0.002 times 16 gives me negative 0.032 plus, again, I'm going in extreme detail here, 0.66 times 4 gives me 2.64, and then when I add those values together, I get the height, so negative 0.032 plus 2.64 gives me 2.608. Now, often there's units here, so it's going to be feet, since that was 4 feet away, so this is going to be feet as well, I assume. It should have said the height of the softball in feet, but if you've got feet in your problem there, that's going to be in feet as well. So 2.608 feet, 4 feet away from where the ball was hit. All right, so the next question, we need to be able to interpret graphs. If given x, find y. If given y, find x. So we have a function here, and I ask you to find f of 0. So that's one of our problems. Then find f of 2, and then find all the x's such that f of x is equal to 0. Okay, now remember what's inside here. This is an, oops, so it's a switch on me. This is an x value, this is an x value. So when x is 0, what's y? This is what this is asking. So when x is equal to 0, what is y equal to? So I go to x equal to 0, and I go meet the graph, and I look at that y value right there. Now be careful, your scale might not be 1, 2, 3, 4, 5. It's not here because that's a 10. So that means this must be 2, 4, 6, 8, 10. So y is equal to 6. So basically f of 0 is equal to 6. This is the 0.06. Okay, the next one asks when x is equal to 2, what's my y value? So I have to go over to x is equal to 2, Now remember this scale, it didn't give us a scale along the x-axis, so we have to assume it's like the scale along the y-axis. I need to be careful about that because you need to know what the x scale is too. So this is, say, 2, 4, 6, negative 2, negative 4, negative 6. Okay, that really needs to be in the problem to be certain, because just because y is 2, 4, 6 doesn't mean the x is 2. But now if the x's are not given, that's what I'm going to have to assume, is that these things match. So I go to x equals 2, which would be this line right here. This is 2. And I go meet my graph. That's this point right here. That would be the point 2. And then what's the y value is negative 4, right? Because again, the spacing or the index is every 2. So negative 2, negative 4, negative 6, negative 8, negative 10, yes. Now what's my answer? When x is 2, y is equal to negative 4. Okay? All right, now this is asking the opposite. They want us to find f of x. That's your y value, okay, when... yes, f of x is 0. So when y is equal to 0, what is the x value? So I go to y is equal to 0 this time. Now y equal to 0 happens to be the x-axis. I'm going to pick a different color to label the points. That's this point right here. That's a y equals 0. This point right here is another y equals 0. And this point right here, all of those are y equals 0 because on the x-axis is y equals 0. So I need to list those values. So x is equal to negative 2 is one of them. X is equal, that looks like 1 right there in the middle. And x is equal to 3. So negative 2, 1, and 3 should be the correct answers when you interpret that graph. For problem 3, we have a piecewise function and ask you to evaluate a bunch of values. The thing is, when you have a piecewise function, only certain x's can go in certain parts of the functions. Here it says my x's must be less than 2. So I only use the top equation when x is less than 2. That's exactly what it says, but I'm writing it down so it can be very clear. On the other hand, I use the bottom equation when x is 2 or bigger, greater than or equal to 2. Okay? Well, negative 1 is less than 2. So I use the top equation. So f of negative 1 is going to equal to 2 times negative 1 minus 5. You need to multiply first. 2 times negative 1 is negative 2 minus 5 is negative 7. So f of negative 1 is negative 7. But look, 2 is 2 or bigger. So I need to use the second equation. So f of 2 is equal to 2 squared plus 1. I'm just plugging in my x into the second equation instead of the first one. Because again, these are directions. These tell you to only use this second equation when x's are 2 and larger. Only use the first equation where x's are less than 2. So 2 is 2 and larger. Then I plug it into the second equation. 2 squared is 4 plus 1 is 5. F of 5. Hey, that's larger than 2 also. So I do f of 5 is equal to, and just plug it in that second equation. So 2 squared, actually 5 squared. We did 2 already. Plus 1. 5 squared is 25 plus 1, which gives me 26. And f of 0, now look at which one do I plug it into? Is 0 less than 2? Yes, it is. I'm supposed to only use that top equation for values less than 2. So f of 0 is going to be 2 times 0 minus 5, which is going to be 0 minus 5, which is going to be negative 5. Okay, so what's in here? What's inside is your x value. The directions are out here, which one to plug it into. You take that x value, 0, and decide, does it fit in the top one? Is 0 less than 2? Yes, it is. Does it fit in the bottom one? 0 greater than or equal to 2? No, it's not. So since it fits in the top interval, then you use the top equation. That's how we did that in summary. Okay, so this problem says, be able to identify intervals of increasing, decreasing, and constant. So remember, increasing means the graph is rising from left to right. Decreasing means it's falling from left to right. And constant means it's completely horizontal. It says, recall that intervals for increasing, decreasing, and constant only use x values to describe the intervals. So first, let's just establish which is which. So increasing, I'm going to highlight that in this color. And let's find where it's increasing. Now this piece over here, that's decreasing. I'm not going to highlight it. This whole piece right here, that's increasing because it's rising from left to right. Then we've got decreasing. Look, then we've got increasing again, rising from left to right. Then we've got decreasing, and then finally we've got increasing again, rising from left to right. Okay, let's go ahead and get it over with and write that answer. I'm also going to write that in blue as an answer. So it says use X values only. Now, I just told you that as a hint. You're supposed to know that. So look at this first increasing piece. I'm looking at this X value to this X value. What about the Y values, you say? Not an issue. Okay, ignore the -4 and the 6. I'm increasing from -8 to -2. Don't put -2 to -8 either. You want to go from left to right, smallest to largest. Where else am I increasing? The next highlighted piece is 0 to 2. Notice I'm ignoring the Y values, the second 0 and the 10. That's not what matters. It's the 0 to 2. Where else am I increasing? 5. And look, it goes up. There's an arrow at the end of there, so that goes forever. So 5 to infinity. All right, now with a completely different color, let's use orange. We're going to highlight decreasing. Again, decreasing means it's falling from left to right. Notice this whole piece, I'm falling from left to right. This piece, we're falling from left to right. And even a third piece, falling from left to right. So when I write my decreasing intervals in orange, notice the arrow here. So I'm going from -infinity to -8. Okay, notice again, don't care about Y values, not an issue. Only X values for increasing, decreasing, and constant. And for any intervals except for range. Range, you use Y values. Look at the next one. I'm going from -2 to 0. Okay, -2 is a smaller number than 0, so I write -2 to 0. And then the last interval starts at 2 and goes to 5. Whenever you write an interval, no matter what you're talking about, you use smallest number to largest number. So notice -2 is smaller than 0, 2 is smaller than 5, always left to right like a book. There are no intervals of constant. A constant graph would look completely horizontal, and this doesn't have any of that. Problem number 5 is composition of functions. It gives you the definition of composition right here. F composite g is defined to be f of g of x. Okay, so if I calculate f composite g of x, that means I'm supposed to calculate f of, and it doesn't matter if you use parentheses or brackets, g of x. Okay, well let's write what that means. We know what g of x is, so I'm going to substitute for g of x. It's right here, -5x plus 4. Now what that's telling me to do is take -5x plus 4 and plug it in the f function right here. Well, if I plug anything into that function, it's going to be 2 times the thing I plug in minus 3. Now what goes in the spot right here is the -5x plus 4. So I write down -5x plus 4. And then you just simplify this expression. In this particular case, we distribute the 2 inside. So -10x plus 8. 2 times -5x is -10x. 2 times 4 is 8. Minus 3. And that gives me -10x plus 5 when I add like terms. That is f composite g of x. Now I'm going to do the opposite, because it asked me the second question, what is g composite f of x? I'm also going to do it in a different color. So g composite f of x. Now by definition, that's g of f of x. So I'm supposed to take the second function and plug it for the x value in the first function. Well, I know what f of x is. I'm just going to substitute it right there. F of x is 2x minus 3. Now this is telling me to do g of something. So I could write the g function down, -5 parentheses plus 4. What goes, that doesn't look like plus 4, does it? Plus 4. Now what goes in there is what's in my spot here to substitute in. So 2x minus 3 goes in this spot. So that's 2x minus 3. In other words, you're taking the entire function, the entire f function, and plug it in for that x right there. So that's going to give me, when I distribute the negative 5 inside, just the algebra, negative 10x plus 15. You got to add 4 to that. So that's negative 10x plus 19, and that's it. Be able to label relative maximums and relative minimums on the graph of a function. Okay, so I want to find all the relative maximums. Y'all, maximums are high points. I don't mean the highest point on the entire graph. I mean like a mountain or a hill that you can hike up or over. So if I circle a maximum right here, my bad. My pen was not selected. Here we go. There's a maximum right there and a maximum right there. There are no other maximums on this graph. Look, this graph goes up forever to the right, and even though those values are higher than these two, but it's not a max. It doesn't flip back around and go back negative, okay, or back down, decreasing. Not necessarily negative at all, but high point, those are maximums. So if I list the maximums, it'd be negative 2, 6, and 2, 10. Sometimes maximum values are just noted by the y value. So you could say y equals 6 or y equals 10. Okay? All of those are correct. If you had multiple choice, it would depend on what the answer choices look like. On the other hand, the minimum values, look, I got a minimum here. It's a low point, like a valley. I have a minimum here, and then I even have a third minimum there. Okay, now this negative 8, negative 4 is truly the lowest point on the entire graph, but relative minimums just mean the lowest point relative to the points around it. And so that means that's why all three of those are considered relative minimums, just like these two are both relative maximums. So when I list the values, I could say at negative 8, negative 4, there's another one at 0, 0, and there's another one at 5, 0. But it also could be listed with just the y values, which is y equals negative 4, y equals 0, and then the other one's y equals 0 also, so there's no need to list it twice, because maximum and minimums are y values, or it could be given by denoting the point. Okay, what is the equation for the function below? Now we know it's a parabola, right? So the parent function, toolkit function, basic function, elementary function, all those words really mean the same thing, and they mean what's the basic graph. So this is a parabola. In other words, we are dealing with an x squared. Now, what has happened to this parabola? Well, it's been scooted to the right 3 units. You know, normally the regular version of this looks like this, okay? But notice it's been moved over to the right 3 and even down 2. So if I list what's going on, right 3, down 2, and look, it's even upside down. This is a reflection in the x-axis, okay? So that means to move it right 3, I have to subtract 3 from the x value, and that way the square's on the outside. To move it down 2, I have to subtract 2 from the entire function, and to reflect it through the x-axis, you put a negative in front of the function. Now what I didn't address was there a stretch or a compression? And I know there's not, because look, for the basic graph of a parabola, on each side you're just 1 away, and look at this one. On each side I'm just 1 away. I'm down, down when I'm to the left or the right one. And more than likely I wouldn't give you one that had a stretch or a compression for you to identify the graph, although it really should have said it here. No stretch or compression. You could actually calculate if it has one as well, but we did not do that together in class. So I want to just keep it simple. No stretch or compression here. Here's a good one. Perform the indicated operation. And you know you can't take the square root of a negative number, but now all of a sudden we can, right? In this class we can, because we've defined that the square root of negative 1 is I. So the long way of handling this is saying, okay, well, this is really negative 1 times 36, and the next one is really negative 1 times 100. And we could take the square root of each of those separately. The square root of negative 1 is I. the square root of 36 is 6. Instead of writing I6, we have the habit of writing 6I. Okay, same idea here. The minus is just moved down. The square root of -1 is I. The square root of 100 is 10. But instead of writing I10 like it's an interstate, we write 10I. And then you have 6I minus 10I is 4I, because you can combine like terms when you're dealing with the imaginary part of complex numbers or the real part. There was no real part to this complex numbers though. All right, one of the most important things you do in math, because it shows up in almost every algebra class ever, is solving quadratic equations. And the very first step is to get the quadratic equation equal to 0. So here I go. I've got x squared plus 6x, and then when I add 11 to both sides, plus 11 equals 0. Now my next step would be to attempt to factor this. What numbers multiply to be 11 and add to be 6? Nothing. Does that mean we can't do it? No. It means you need to use the quadratic formula. Very important to have quadratic formula skills. So here I go. X is equal to, remember, negative b. By the way, if you need to list what a, b, and c is, let's do it. So a is 1. A is always the number times x squared. B is 6. B is always the value times the x. It's always the x coefficient. C is 11. Okay, so when I plug this in, you've got negative b, so negative 6, plus or minus the square root of b squared, so 6 squared, minus 4 times a is 1, times c is 11, and that's all divided by 2a is 1. So that gives me negative 6 plus or minus the square root of 36 minus 44, all divided by 2. I keep simplifying. That's negative 6 plus or minus the square root. Now what's 36 minus 44? Negative, you say. Negative 8, right? Is that awful? No, it's just imaginary, or it's a complex number. So we can do this, right? The square root of a negative is an I value. So you have negative 6 plus or minus I square root of 8 over 2. Notice when I handled that negative, it came out as an I, and now it's no longer in there. But you know what? Square root of 8 can be simplified also, because you can say negative 6 plus or minus I. Square root of 8 can be written as 4 times 2. And then the square root of 4, this part right here, is 2. Now the square root of the 2 part must stay underneath the square root. So that gives me negative 6 plus or minus 2i. Notice I put the 2 in front of the I, and then square root of 2 from here stays underneath. And then finally, check this out. This number, and this number are all divisible by 2. So that's what I can do. Really what you're doing is factoring out the common 2 and then canceling with that 2. But a cute little trick is divide all of those by the same number if it can be done. And it can. So negative 6 divided by 2 is negative 3. 2 divided by 2 is 1, so I'm just going to not write it anymore, because 1 times something is itself, and then 2 divided by 2 is 1. So there's my 2 answers. If you had to list them separately, one of them is negative 3 minus I squared root of 2. The other one is negative 3 plus I squared root of 2. Now, if I was asking you about x-intercepts, the work would be exactly the same, yet these wouldn't count as x-intercepts because they're not real numbers. But if I'm just asking to solve, then we definitely have 2 complex solutions. All right, so this time we have an application problem, and you might have made it through this class without doing a lot of these, if any, but it's going to show up on the final, so we got to know how to do it. It says you have 200 feet of fencing to enclose a rectangular region. Draw a picture if you need to. So I'm drawing a rectangular region. And all I have is 200 feet of fencing to go all around that rectangle. It says find the dimensions of the rectangle that maximize the enclosed area. So if I want to maximize area, then I'm going to need to call it something. How about area equals, and how do you calculate area? Well, it's length times width, right? So if you want to call this the length and this the width, that sounds like a good idea. So area equals length times width. All right. But then we have this thing called a constraint equation. And my constraint equation is the fact that I only have 200 feet of fencing. So I have 200. Now what's it got to do? It's got to cover an L, a W, look, another L, and another W. Well, that's 2 L's plus 2 W. That's perimeter of a rectangle. So that's our constraint equation, which is about how much fencing we have, but we're trying to maximize area. Now your next step always is going to be to solve for either L or W in your constraint equation. So I'm going to solve for, doesn't really matter, I'm just going to solve it for L. Okay? So to do that, I've got to subtract 2W on both sides. I need the L by itself. So on the left I have 200 minus 2W. On the right I have 2L. Well, L is not by itself yet, right? I need to divide both sides by 2. Now what is that going to do? That's going to give me L by itself. Look, I'm going to write it the other way around. L equals, now look, both of these divide by 2. 200 divides by 2, that gives me 100. And 2W divides by 2, that gives me minus W. Now remember that dividing by 2 thing? You could only do it if both of these divide by 2. Or you could split it up into 2 separate fractions, like 200 over 2 minus 2W over 2, and then simplify it. That's the smartest way to do it. All right, now what am I going to do? I'm going to substitute L equals 100 minus W into the max-min equation. Okay, so I have area equals L, which is 100 minus W. So look, I removed the L. Ooh, I didn't mean to do that. I'm supposed to be using a highlighter. I'm sorry. I removed the L, and I replaced it with what L is, which is 100 minus W. Now that W right there is still next to it, just like that. So this was L, and now it's 100 minus W times the W that's already in the equation. The reason I did that is because now I have a quadratic equation with just one variable. So I distribute the W inside. That's 100W minus W squared. I can write that in descending order, which is minus W squared plus 100W. And I'm supposed to maximize it. Now what I'm trying to do is to find the maximum or the minimum of this. It's the maximum of this. Now to do that, you need to find the vertex. Y'all remember how to find the vertex? Remember, the vertex is x is equal to negative b over 2a. A lot of classes struggle to remember that. Remember, it's really just the first part of the quadratic formula. So this is going to be negative. Now my b is the 100. Remember, your a, highlighter, your a is the number in front of your w squared, your b is the number in front of your w, and your c is your constant out here. Again, let me, in a different color, a, b, c. Now c apparently doesn't matter, right? It's not part of our formula. But I do have an a and a b to deal with. So negative b, so it'd be negative 100 divided by 2 times a. My a is negative 1. So that gives me negative 100 divided by negative 2 is 50. So my x is 50. Oh, I changed it to x. You know what? My vertex isn't x. Why not? Because when I use the quadratic formula, it's w. It's whatever variable you have in your equation. So it's w is negative b over 2a. So my w is 50. Okay? How do I find my length? Well, look, there's a formula right there. Length is 100 minus w. What's our w? It's 50. So 100 minus 50. Oh, my length is 50. So my length is 50 and my width is 50. Now again, we may not have done much of these in class, and so that's something that you might want to spend a little extra time doing. If you have questions about that, do let me know. The one that goes on the final is very, very, very similar to this, so make sure that you can do it. Okay, the last problem that I plan to do for part 1 of this final exam review is number 11. It says calculate the zeros of a polynomial function. Be sure to set the function equal to 0, then attempt to factor the factor, then function completely. Wow, I must have been really in a hurry when I created this review. I do apologize. Then attempt to factor. This part should not be there. To factor the function completely. Then set each factor equal to 0 and solve. Okay? So, factoring may be not bad. Factoring may be terrible. We're about to find out, aren't we? Now, when I first look at the, first of all, set it equal to 0, just like it said. So whenever you're asked to find the zeros, that is the first step. No matter what you do after that, you got to set it equal to 0. Okay. Now, hey, I see greatest common factor. An X is in every one of these. Now, they don't all have a 6 common factor, but they all have a 2 common factor. So you know what? I'm going to pull out a 2x. That's going to leave me with 3x to the third, right? Because 2x times 3x to the third gives me 6x to the fourth, so we're good there. 2x divided into the negative 4x to the third is negative 2x squared. 2x divided into 6x squared is plus 3x. And then 2x divided into negative 4x is minus 2. If you struggle to do that, let me show you. Whatever your greatest common factor is, put it out front and divide each one of these by 2x, and you might be able to see better how that's simplified. Now next, we would have to do some synthetic division and find a list of possible rational zeros, except for the fact that factor by grouping might work here. Look, if I group those together and those together, what comes out of here? X squared. And always look for factor by grouping if you have 4 terms. X comes out here, x squared comes out here. That leaves 3x minus 2. Look, nothing comes out of here. There's nothing in common to 3x minus 2, so I'm going to put a 1 out front. But the great news is what's in parentheses matches. So don't forget to copy that 2x we pulled out front, big brackets. The guy that matches, 3x minus 2, times what's left out front, x squared plus 1. That is completely factored. I'm going to write it at the bottom of the screen. This is 2x times 3x minus 2 times x squared plus 1. So again, this is completely factored. I bet you're thinking, why don't we factor the x squared minus 1? Because it won't factor. X squared, did I say minus 1? X squared minus 1 would factor. X squared plus 1 does not factor. Okay? So does that mean we can't go any further? No. We set each factor equal to 0. Okay, so I'm going to change colors on you so you can follow. So one of the first factor is 2x. I'm going to set it equal to 0. 3x minus 2, I'm going to set that equal to 0. And x squared plus 1, I'm going to set that equal to 0. 2x is equal to 0. I divide each side by 2 to get x is equal to 0. 3x minus 2 equals 0. I'm going to add the 2 first to get 3x equals 2 and divide both sides by 3 to get x is 2/3. And then finally, this guy, you could use the quadratic formula with a is 1, b is 0, and c is 1. Or, because it doesn't have an x term in this quadratic, you can just subtract the 1. X squared equals negative 1. And take the square root of both sides. Don't forget to put the plus or minus whenever you have the square root. So x is plus or minus the square root of negative 1. Y'all know that's the same thing as I. Now, how many zeros do I have? Remember, you know, there's 4 of them, right? Because it's a degree 4. So we have them all listed. 0, 2/3, negative I, and positive I. Okay, so that was a factorable problem. Come back for part 2 where I'll start working on problem number 12 and finish this review out.